All right, now one thing on it, when the ASE test, okay, they talk about obviously they have their own specifications because it's a composite vehicle. But with that said, anything we go outside the composite vehicle, understand they following a certain theory on a regular car, as you said, GM car. Well, that's in my opinion. All right, but you just gotta go with this. You gotta go with their specifications, but you're gonna use your basic knowledge of the system, but apply their own specification. You know what I mean? Like for
So they are the same.
yeah, it's basically the same, but you gotta use their specs and their procedure. Like for instance, let's say a TBS, the offset is on a offset TPS. Let's say I'm gonna make this up. It's point 0.5 on 1 volt. But on the AS, as they go up, they're half a volt offset. Not making that up. On the ASC test, it's 1 volt offset, but the same theory. You know what I mean? You just got to use their specifications. If that makes sense. In other words, you got to apply basic knowledge to their vehicle. Does that make sense?
Yeah.
All right. So remember you got to use their specs and apply basic knowledge to their car. Okay. So now here's an advanced EVAP system. Okay. We have the EVAP canister, which stores the vapors. We have the fuel tank pressure sensor. It's located on the gas tank. All right. And it's a you can see it's a 3-wire sensor. 1, 2, 3. It's a pressure sensor. It's got 5 volt signal and ground. And you can see here it goes to the PCM. And the only thing this is used for is testing. That's what it's used for. Pressure and vacuum. That's what it's used for.
Okay.
We got the fuel cap. And that has to be sealed. We got the fuel level pressure sensor, right? Fuel level pressure sensor inside the gas tank. No, I said fuel level pressure sensor. Fuel level sensor inside the gas tank. Okay, and remember the fuel level sensor is for the PCM to meet the engineering criteria to run the test. So if this is off, it's not going to run the test. And remember, this ain't the same gauge. Well, it is, but the PCM ain't looking at the gauge on your dashboard. It's looking at this. There could be a trick question relating to that. I remember I ran a test one time. I said, "Oh no, you're not." They have a question, and it's relating to the gas gauge on the dashboard, but the one on the scan tour reading is this, and this is what the PCM looks at. That makes sense? Because remember, it's 15 and 85, right? 15% to 85% to run that test, and this was off. But the gas gauge on the dashboard read a half a tank. So in your mind, you'll think, "Oh, it should be able to run the engineering criteria." No, that ain't the point. That ain't the part that runs the engineering criteria on. It's this sensor here. And you find this on your scan tool, parameter identification data, right? Okay. It tells you the level of the fuel, and it actually tells the PCM the level of the fuel. All right, a normally closed purge valve, and remember that's normally closed. It's open to normal operation and testing, and obviously the service port for leaks, and what's an vent valve. You can see here that's the vent valve. It's normally open. And it closed for testing. It's the only time it's closed is for testing. And look at this. See this right here? Fresh air. I gotta get the pointer. I'm on a PowerPoint, so I can't draw like I did this morning because it would lock up for some reason. So right here is fresh air. Okay? This is normally open. And remember, the fresh air helps vent the canister and canister hooked up to the tank. So if this vent, anything restriction in this line, right? Any restriction in this line can cause excessive pressure in this system, and it goes back to the tank. And only way it can get out is through this, right? So you gonna fill the gas up, put the nozzle in there. All that pressure in the tank is gonna go back up this way and turn off the pump. Okay, and remember, even in the composite vehicle, they have this overflow tube here also. So it's the same. It's a different picture. Let me see something. This is the same system here, right? Look, see this tube right here? overflow valve, the vent valve. Even though it's the same system, it does the same thing. This is vented this way. This is going to the PCM, right? And it's going to the canister. Again, if this is stuck closed, or this is restricted, right? They're going to have pressure in the system going through the same line into the tank, and all that pressure is going to be built up in the tank. So the only way you can get the pressure can relieve itself when you take this cap off and you put the nozzle in there. You can't fill it with gas. It's the same criteria. So if this is restricted, and even this, all that pressure goes up this way.
With back pressure.
It's back pressure.
Okay.
Okay, now where's my thing at now? Where you at? Okay, now it says the EVAP system canister is filled with a charcoal carbon that stores fuel vapors from the fuel tank. Control engine vacuum purges fuel vapors and air from the canister during certain driving conditions. Obviously, we know that that's how the canister works. Right? And we're talking about this canister right here. During normal driving conditions, fresh air comes in here, help push the vapors out during normal purging when the purge valve opens up, and it goes into the intake system to be burnt again. That's a normal operation of the EVAP system. The normal closed purge solenoid is a pulse width modulated by the PCM to precisely control the vapor flow. This is right here. This is the purge flow right here. Okay? So what happens is it's controlled by the PCM. Right? It says here pulse width to control the purge flow out the canister to be burned. When energized, the EVAP canister purge solenoid allows fuel vapors and air to flow from the canister to the engine. Where's the air coming from? The vent valve. The vent valve. So this is normally open. Air goes in here and help push the vapors out past the purge valve into the intake system.
Yeah.
Okay. So this actually helps relieve the pressure in the system and also helps purge the system. Now look at this. The purge valve can set a DTC P0442 and at the same time cause ICO. How does it do it? If this gets stuck open or leaks. If the canister is filled with vapors and it's supposed to be closed, it can leak past the purge valve into the intake and burn at the wrong time. Then you could get a high CO, high emissions.
Okay.
But now I have seen this also when it causes a lean condition. Surprised the hell out of me. Every time I see that purge valve goes bad, it's always rich. It's always rich. Every time I've seen it. One time in years, I seen this sucker leaking and was lean. I said, no way. I didn't believe it was a bad part, but I ended up fixing the car. I was shocked. Now, the reason why is because when it's filled up with vapors, obviously if it leaks, vapors go by it and burn because it's fuel vapors. But let's say that the canister is empty, no vapors in it at all. It can run lean.
Oh, so it's pulling in
just air from this.
Just air.
Right? Now I read about that, but I never seen it until that one time I seen it. And it surprised the hell out of me. I said, there's no way causing a lean condition. It used to cause a rich condition. Most of the time it's high CO, but it could cause lean also.
There's a possibility.
Now keep in mind, even though I'm talking about this, keep in mind, you got to relate this to the composite vehicle, okay? Even though it's a little different from the composite vehicle, but guess what? A leaky purge valve is a leaky purge valve. You see what I'm saying? Yeah, it's the same conclusion. Yeah, Now look at this one. A stuck closed purge valve can set a DTC P0455 and at the same time cause large leaks. Now, P0. Now this is what I'm just saying here. T0455, right? It's a large leak code. Okay? That means that the system was tested and found it has a leak. And we found out it was due to a purge valve stuck closed. Now understand this, a purge valve is normally closed. Okay, now pay attention to where I'm going on with this. It's normally closed. So I'm saying I got a purge valve that's stuck closed, and that's a normal position, closed. Okay, that's a normal position of closed. And yet it's causing high CO, just like this one did. Just like this, a leaky purge valve. Alright? But I'm also have a large leak code. So on this one I'm saying that a stuck closed purge valve can also cause a large leak code.
How?
Now that's a very good question. Now think about this. When an EVAP system meets the naming criteria, it needs to pull a vacuum. How to test for a vacuum, I'm going to show you later on. It closes the vent here, right? And opens the purge valve, and the purge valve pulls the system to a vacuum. And the FTP sensor here looks for the vacuum. So you get that so far? So let me say it again. When doing a leak check, okay, on a leak check, this closes.
Yes.
Okay, this opens.
Correct.
The system goes into a vacuum. The FTP sensor here watches for a vacuum to hit a pre-designed number.
Wow.
If it doesn't see it goes into that vacuum, it sets a large leak code. For instance, let's say the gas cap is off or leaking. That's a large leak. No matter how much this thing is pulling a vacuum, if this gas cap is off or got a hose in one of these lines, it can't get to that vacuum criteria. Whatever that number is supposed to be, I can't reach it. The target number to pass. Whatever that target number is, it can't get there because there's a leak. Let's say it's supposed to move. Let's say the PC1C at 1 inch 1 inch of mercury change, inch of water, mercury of water change, right? We see it, inches of water. It won't see inches of water, right? It won't see 1 inches of water of change. And it doesn't see nothing, right? It's looking at, okay, let me say it this way. It's looking at inches of water and looking for a change in that number off the FTP sensor. Either in inches of water or a voltage number, okay? So it's watching this sensor. That's the only thing it does is watch this sensor. It knows it turned the purge valve on. It knows it closed this valve here. So now it's going to look for a change here to go into a vacuum. Like I said before, if this gas cap is off, it cannot see that vacuum, so it's going to set a code. If a hose is leaking, it cannot see that number, it's going to set a code. Now think about what I just said. If the purge valve is stuck closed, and I just commanded it to come on, and I close this, do you think it's going to see that vacuum?
No, because it's not letting it in.
Exactly. That's how a stuck purge valve can cause a large leak code also. Right? Even though it's closed.
So the FTP is gonna assume it's because it's leaking. But in reality, what it is you don't have vacuum present.
Exactly right. You're exactly right. Right? We had a car like that, man. It took us almost a week to find that, and the sucker was closed. But anyway, it's the same thing on the composite vehicle.
Okay.
The EVAP canister vent solenoid replaces the fresh air vent used on past canisters. The normally open vent solenoid not only allows fresh outside air to the canister purge during purge modes, but also can be commanded closed to allow the diagnostics to draw a vacuum in the fuel tank. It's basically what I just described. The fuel tank pressure sensor mounts at the top of the fuel sending unit, which is right here. The sensor is a 3-wire strain gauge sensor, such like the common MAP sensor. However, this sensor measures the difference between air pressure or the water. Inches of water right here. Thank you. It's inches of water right here. Right, inches of water, fuel tank pressure sensor, fuel tank, inches of water, and a fuel tank pressure. Right, damn, I'm like the same scale. 2.5 here, right here is atmospheric pressure. It's 2.5.
Atmospheric pressure.
Right. So where that number may be sitting at here is looking for a change. So obviously, you put the cap back on there. We're going up to a pressure. We're going to a vacuum. We're going this direction. Okay.
So vacuum would be lower voltage, right?
On this car, yes. So right here, here's a vacuum. So that's easy. That's a good question. Let's go this way.
Yeah.
I'm right here. I'm at right here, atmospheric pressure.
And then
that's 0 right here, right? So if I'm going to a vacuum, let's say I go to negative. What would it be? Just a negative. I don't know.
Negative
3.
4?
Yeah. You can see the voltage went down.
1.25.
Yeah, 1 to 2. So right here, when I go to a pressure, let's go to 6.
That's about 0.400.
You can see a pressure, I got higher voltage. All right. And a vacuum, I got lower voltage. Yeah, right. So that's good to know because when you read this chart like that, you got to understand which way is going to a pressure and which way is going to a vacuum. Remember, the negative is a vacuum. Right, the negative number right here is a vacuum, and this is a pressure. That's actually I didn't think of that. That's actually a good question. All right, so they actually relating to that. You could tell what the voltage is supposed to be if they give you numbers by reading this chart.
That's I'm just trying to relate it like into those basics. So
yeah,
you got zeros. That's atmospheric pressure. When the voltage drops, that's vacuum. That's vacuum drop. When the voltage increases, that would be actual pressure.
Pressure, yeah. Now let me ask you this then, since you said that. What in the system will cause a pressure?
What in the system will cause pressure?
Yeah, what will happen to the EVAP system for the pressure to build up?
I would assume at some point it would cause a leak.
No. Well, a leak will be, yeah, you're right. A leak will be pressure. Let's say a leak could be pressure not changing, right? That's true. Let's clear that up though. That would be a pressure if I'm looking for a vacuum, and the system remains in a pressure state. So that's a leak. You understand what I mean? If the system comes on and is looking for a vacuum and it stays in a pressure state, then you know you got a leak. Now, under a normal situation, what would cause the pressure to increase?
Well, the purge valve would be stuck closed, right?
Can you explain more than that? Because the purge valve is always closed, unless it's working.
What would cause the buildup? Well, because I'm assuming if the purge valve is closed, it's not allowing any of that pressure to go into the intake. You basically have a closed system.
Now remember, the pressure is not in the intake; it's in the gas tank. It's in the gas tank.
The gas tank.
Intake is vacuum. It's the gas tank.
Okay, so maybe you have a collapsed hose. Like in the canister.
Okay.
You would have a collapsed hose that's not going.
Okay, now that's true. But let me ask you this though: on a normal operating system, what would cause the pressure to increase? No problems with the system, but at one point the pressure has to increase.
Point. When you're fueling?
No. How about when the vent valve closes?
Oh, okay. Yeah, you're not drying.
Yeah, when the vent valve closes,
Yeah.
when the vent valve closes and the purge valve is normally closed, the PCM is going to look for a pressure increase when it tests the system. Mm-hmm. So what you said earlier, it should see a slight increase, right?
Right.
If it doesn't see that increase, it knows the vent valve probably didn't close. Now, I can ask that same question the other way around. But you answered this earlier. What can cause a vacuum in a normal operating system? Right? The purge valve opens and the vent valve closes. Let me back that up. There's two ways. The vent valve opens and the purge valve opens. The vent valve in the normal open position and the vent valve opens during testing. All normal operation. It can cause a slight vacuum. Because we got a vacuum on the system. Now, you close the second way is when it's testing the system, right? The vent valve closes and the purge valve opens. It draws a bigger vacuum on the system.
Mm-hmm.
Because now the vent valve is closed. I had some scan data I'm going to show you, but you understand what I'm talking about?
Yeah.
All right. So the reason I'm saying that, you have to understand, because they may, on the ASE test, they may ask you about the purging and pressure on the EVAP system. Now it says the system service port has a green cap and is located on the holes between the purge solenoid and the canister. We already know that. The port contains a straighter valve, reverse threads. The fuel cap is an important part of an enhanced EVAP system. In addition, it is normal duties of fuel system containment. The cap must maintain a leak-free seal in the filler neck. Okay, we already know this right here. We know that already. Improper or adequate sealing may cause the PCM onboard EVAP canister to fail the EVAP system and turn on the mill light. Now we're talking about the fuel level sensor here. It says the PCM performs an onboard enhanced EVAP diagnostic test. It says most PCMs run enhanced EVAP diagnostics when fuel levels between 15 and 85%. Now I already explained this, right? This is one that you see on the scan tool, not the one on the dashboard.
Correct.
Because don't get that confused. Because they may ask you on the ASE test a trick question based off that. That's the scan tool reading. Remember, what you'll see on the scan tool, what the PCM is saying.
Okay.
All right, here's some of the enhanced tests. The diagnostics uses several different tests to evaluate the status of the EVAP system. Power up vacuum test, excessive vacuum leak test, weak vacuum test, small leak test, and the purge solenoid leak test. The diagnostic uses several different tests to evaluate the status of the EVAP system. You must remember there are enabled conditions that must be performed to detect a problem. We talked about enabled conditions before, so that should be a problem. Yeah. The vehicle needs to be driven long enough to perform a trip-or drive cycle to trigger the mill light. We already talked about what a trip and drive cycle was in the first class. The power-up vacuum test is a passive test designed to detect restrictions or blockage in the vent system. All right, see, understand what this is saying? Because there may be a question relating to this on the ASE test. Mm-hmm. It says a test designed to detect restrictions or blockage. This test runs when the EVAP solenoid is open and the purge solenoid is closed. All right? The engine is cold and the key is in the run position with the engine off. The fuel tank pressure sensor should not indicate pressure or vacuum within the vent solenoid when the vent solenoid is open. So you get that? The fuel tank pressure sensor should not indicate a pressure or vacuum. All right, because the vent solenoid is open, right, and the purge valve is closed. It's normal state. It should not see excessive pressure beyond specifications, and it shouldn't see a vacuum. If it does, it's going to cause excessive. It's called what's it called? Excessive purge, right? And that could be on the ASE test. So basically saying is, if we got a restriction somewhere, or we have a restriction, it could cause excessive purge code, or give you excessive purge on the scan tool readings. So power scan passive test designed to detect restrictions or blockage. This test runs when the vent solenoid is open and the purge solenoid is closed. That's a normal state on a cold car. If the key is in the run position with the engine off, the fuel tank pressure sensor should not indicate pressure of vacuum. This test will only run when the fuel level is between 15 and 85%. Okay? If it sees pressure, you get a code for that. If it sees a vacuum, you get a code for that. Right? And remember, vacuum is purging, excessive purging. A blockage is pressure. Because we just went over that, remember? If I see purging, excessive flow. If I see a pressure, right, it's too much pressure in the evap system. You get a code for either one. And guess what? It depends where the problem is located at. All right? And what can cause that is restrictions or blockage in the evap system. Right? And remember, it's looking at this fuel tank, vent valve, and purge. What we just described was this is open, this is closed. And if PCM runs that power up test, it's going to watch this to make sure there's no excessive pressure in the system or vacuum in the system. All right? If it is, we got a blockage somewhere. Or restriction. Here's excessive vacuum. Excessive vacuum test is a passive test designed to detect vent path restrictions. See this? Vent path restrictions. Now, this is excessive vacuum. What's going to read excessive vacuum? This. You get a code for this, and then on the scan tool data, it can show excessive vacuum by reading this. Remember, the numbers will be into a vacuum on the scan tool. So if they ask you about that, that's excessive vacuum on the system. And what can cause that? It's a passive test designed to detect vent path restrictions. Your vent path is restricted. Either the hose going to this is plugged up, this is stuck closed, this hose is plugged up, right? If it's plugged up, it can cause excessive purge flow at the wrong time. This test runs during normal canister purging. See right here? Right? We showed this earlier. Let's say it's supposed to go from 2.5 in normal purging to 2. I'm using the composite vehicle numbers. Right? Remember, that's from 2.5 to 2. That's what it's looking for. But yeah, I'm at 1. -1. That's excessive purge flow. You remember the chart. See right here. This is the cap off right here. Normal pressure. But when the cap is on normal condition, I might be around here at 2. Okay? Somewhere around here. Normal conditions. Slight purge. Normal operating conditions. Cap is on, vent valve is open, purge valve is open during normal conditions. I might be around here around 2. So the EVAP is going to test the system. If it sees 1.5, 1, when it's supposed to be over here, that's excessive purging. And what can cause excessive purging? Only time it gets this far down if the vent valve is closed. So if the vent valve is supposed to be open, something is wrong. Either it's plugged up or stuck closed or a restriction in that line, causing it to have excessive purge. And remember, only time it gets down this far when we're testing for an evap leak and it pulls it into excessive purge, pulls it into a deeper vacuum, pulls it into a deeper vacuum. All right, so say that again. In normal conditions, let's say I'm supposed to be around here, but it sees 1.5 to 1. And to the PCM strategy, that's excessive purging. Right? So only thing can cause that is a restriction in the evap system. Which one? The evap system. And what can cause that is the vent valve is closed up, this hose is closed up, or some kind of restriction in that, some type of restriction in the vent path, right? Some type of restriction in the vent path. Now, even though this is a different diagram from the, right, this is what I should be showing you. So even though that picture I showed you earlier is different, why do you keep coming up? I don't understand. See right here, even though I'm talking about this restriction here, because it's easier to look at, the restriction in this EVAP system here, it's the same thing. I'm sorry, I said EVAP. Purge system, I mean vent system, golly. In that vent, it's the same thing with the vent solenoid here, right? It's the same thing with the vent solenoid here. A restriction in this system here, here, on this line here, all this line here going to the tank can cause excessive purge. Because this is supposed to be vented. So if it's plugged up and this purge only comes on, I'm going to draw it into a deeper vacuum than it's supposed to be. So again, say normal operating conditions, this is open, the node line is collapsed, my purge valve opens, I go from 2, I'll make up the numbers, from 2, going 2.5 to 2, normal conditions. That was the piece it wants to see. Instead of seeing that, it goes to 1.5 to 1. So it can cause excessive purging, the vent valve close, restriction, any lines. It can cause that. Right? A restriction in the lines can cause that. And even this line right here. Right? Because the vent side is closed. Right? And it's supposed to be vented. So I got a restriction in this line over here, stuck closed here. It can cause excessive purging. Oh, hell, even this line right here can cause excessive purging. Because everything's supposed to be open. If it's open, this is the design leak. So this whole side's a leak when it's normal, not a leak, but it's a design vent, especially up here. It's a design vent.
Yeah.
Right? So if I have a small vent, I can't go into, the vacuum can only be created so much. But if it's blocked off, here, or here, and when this opens up, I'm going to a deeper vacuum. Now I forgot, did I miss this? So we just talked about excessive vacuum. So the excessive vacuum test is a passive test designed to detect vent path restrictions. Okay, we just said that. The fuel tank pressure sensor should not indicate excessive vacuum during this test. Okay, we said that already. And we talked about that. Here's another one. The weak vacuum test is an active test designed to detect gross leaks. The test commands the vent solenoid closed during normal canister purging. So now it's going to check for a gross leak, and the vent solenoid is going to be closed. This one is testing the system. A purge valve that doesn't open can cause a large leak code. We talked about that already. We already explained that. The fuel tank pressure sensor should indicate a vacuum during this test. Now in this case, this is when we want to see that large vacuum. Okay, because now the vent valve is going to close. Now we should be able to pull a stronger vacuum now because the vent is going to be closed. All right, so if the vent valve sticks open, or leaks, or you got a leak somewhere in the system like the gas cap or hose, I can't pull the target vacuum. That's where you get a code for a large leak. So what we're looking at, So we're looking at now that this purge valve is going to close. This vent valve is going to close. The purge valve is going to open. Command by PCM is going to duty cycle it and watch for a larger vacuum on the sensor. Okay. If there's no leak, it should hit the target vacuum. If the gas cap, hoses, vent valve, hoses, evap canister, hoses, or even a vent solenoid is malfunctioning, you get a large leak code. A small leak. A small leak test is an active test designed to detect a minor leaks. This test runs immediately following a passing weak vacuum test. So if that test we just talked about passes, now it's going to look for a small leak. How does it do that? While the vacuum is still present in the system, right, in the fuel tank, the vent and purge are commanded close. Now, okay, so check this out. So we went into a vacuum. Say we pulled the target vacuum 1.5. I'm just making up that number. Say the target was 1.5. We met that criteria. Now we're going to close off the vent and close the purge valve and trap the vacuum. And now the test is going to monitor the fuel tank pressure sensor for vacuum decay rate that is too fast. Now we're going to go to a vacuum and see how fast it goes back to a pressure. So you get that? Mm-hmm. So it's going to go the other way now. It's going to watch and see how fast it goes back into a pressure. Mm-hmm. If it goes back to a pressure too fast, it's going to say a small leak code. And what that means is it's going to say, let's say it just did the large leak test and it pulled a vacuum to 1.5. Mm-hmm. Okay? It passed that test. This was the target vacuum. It hit this number, hypothetically, and it passed. So what it's going to do is going to trap the vacuum now. Now it's going to watch the FTP sensor for a pressure change and see how fast it's going to a pressure. Which way is pressure? Going this way or going this way?
Going that way. Going a higher voltage.
Yes. So it's going to trap it around 1.5. It's going to see how fast it goes towards atmospheric pressure, which is 2.5. Mm-hmm. If it gets there pretty quickly, it's a small leak somewhere. But if the pressure increases slowly, and under the criteria number to pass, you get a pass. Mm-hmm. So this way it's looking for a pressure change. So I just explained that. Yeah. So what it's going to do is, it ran a test, right? It had this closed, this open, and watched the FTP sensor for a vacuum. Once it hit that vacuum criteria, right, it's seen it and it passed. It closed the vent, closed the purge solenoid and the vent, and watched the system for a pressure change. Watch the FTP sensor for a pressure change. If the pressure increases slowly, there's no leak. If it increases too fast, there's a leak, small leak somewhere. And here's another picture of the EVAP system. This was just for class. So you got the pressure sensor, vent solenoid, purge solenoid. That basically was just for the class. I got this from. I don't think I need to go that again. The vent is, see here, the vent is only closed during testing. We said that. A stuck closed purge valve can cause a P0455. We explained that already. Okay, here's the leak detection, the smoke machine. I remember the smoke machine also. This is the indication of a leak here. You set that for a 20 or 40,000 leak. If this ball is at the bottom, there's no leak. When it starts to rise, it's a leak. A lot of people think it has to go past this number. To set a code for a leak. No. If I set this for 20,000 and that ball right here, if this ball here rises just below this arrow, it's probably a leak somewhere. It's about to set the light.
Yeah.
All right. That's pretty close. It's probably going to set a leak code. A purge seal test indicates of the following: the purge valve to open, the vent valve to close, the fuel evaporator system to hold vacuum. And basically what we said earlier. Here's the solenoid, here's the purge valve. It's just, this right here is just an easier picture to look at.
Yeah.
All right. We close this, we pull a vacuum here, We close this, and we check for a change.
Gotcha.
And here's just the graph of the fuel tank pressure sensor. Now remember, this is a different number than a ASE composite vehicle. Okay, but use the same theory. Fuel cap off on this card 1.5 to 1.7 on the ASE test ASE composite vehicle is 2.5. All right, but with that said, the negative reading indicates a vacuum. A positive number indicates a pressure. The same theory applies. We just got to change the numbers.
Yeah. 2.5.
Yeah. As most of the whole thing works, right? It's based off another card. They just changed the numbers. Yeah. Now look at this. Look at the EVAP vent solenoid on this case here. It's venting, right here. That means it's open. Look at the purge solenoid, 18%. Right? That's normal operating condition. Look at the FTP sensor. Right here. See this? It's a negative 0.1, negative 10 millimeters of mercury. Right?
Sorry,
that's a normal condition. Okay? All right. Now again, on a composite vehicle, you change this to inches of water. But you use the same concept. It's in a vacuum. Right? 18%, a slight vacuum. That's a slight vacuum. Because the vent valve is open right here. Look at and the purge solenoid is working during normal operating conditions. We talked about that. Mm-hmm. Now, this is what happens when it tests the system to a bigger vacuum. Not venting. Look at this. Now it's closed. See what happened? Now it closed. Oh, sorry, right here. Now it closed. See, the vent solenoid closed now. My duty cycle stayed the same. Oh, come on. Oops. Look, right here is venting. It means it's open, 18%. Minus 0.10. Not venting, 18%. But look at this. So not venting is blocked off now. Now look at the FTP sensor. You see what I mean when I say it goes to a deep vacuum?
Yeah.
That's a pretty big vacuum. And that's why I said if this is normal right now, but remember that situation where I said excessive EVAP flow? That would be excessive if this wasn't commanded close. If that was open, like I got a number like that, that's excessive flow. Oh yeah, I forgot to say about the voltage too. Look at the voltage. It's 4.5, which is normal. Right here, venting, right? EVAP, the vent valve open, 18%. Look at the voltage, 1.5. All right, on a composite vehicle, probably 2.5.
2.5.
Right? Now it's venting. Not venting means it's closed, still 18%. Look at this deep vacuum. So look at the voltage, I'm sorry. It went to 4.5. What was it before? 1.5, right? Now, with it closed, it went to 4.5. Right? Now, here's the thing. This one went up because it's a GM. But on the composite vehicle, it's going to go down. So don't get confused with this. Remember, I said use the composite vehicle chart. But it's the same theory, though. You understand what I'm saying? Don't get confused with this number because this went the opposite of the composite vehicle. It's the same theory. You get it?
Yeah.
All right, so don't get confused with that number. Because on the composite vehicle, it's going to go to a lower number, I think it was, wasn't it? It's going to go to a lower number. But it's still a big jump. Use that same theory, but use their numbers.
Yeah.
Now, here's a forced EVAP system again. I don't think I should. Right. Duty cycle. What I'm doing here. Look at the purge solenoid first. Right. So it's 0. Look at how the IAC is responding. Not responding much. And look at the fuel trim. Short-term fuel trim. Bank 1 and bank 2. Now look here when the purge valve comes on. At this point, the purge valve is coming on. Here the purge valve is off. Here it's coming on. Right? IAC responded, and look at the fuel trim now. It went negative. Because right here it went rich. This is another way to indicate. That the purge valve came on and is working. Right? This is another way to indicate that the purge valve came on and the system is working. By watching the fuel trim and the IAC. Remember, this went rich. Right here, it's a lean command.
Yeah. Bank
1 to bank 2. Here's another one. Look at the purge solenoid first at top. Look at this. Purge valve on. Vent solenoid turned on right here. It's off right here. Turned on here. And look at the FTP sensor. It went to a vacuum. Right? It's off here. And all of a sudden it drops into a vacuum. Indicating that the purge valve is working. And the vent valve is working because I've seen a change here. Now here's the EVAP system criteria check for leaks. I just explained it on the other example, but here's the actually ASE composite vehicle. Test for small leaks. This is an EVAP system and large leaks. This is engine off natural vacuum leak detection is used to test for small leaks. And this is a natural vacuum leak detection. And actually using the atmospheric heat to check for leaks. Yeah. And their criteria for small leak, the vehicle must have driven for 15 to 90 minutes. The fuel tank must be between 1/4 and 3/4. And the air temperature must be between 40 degrees Fahrenheit and 105 degrees Fahrenheit. Key is in off, engine's off. This is an example to like a gas can, right? The red gas can, you stick it in the sun, it has pressure in it.
It
expands, exactly. You put it in the shade, it's going to contract. This is what this concept is from. When the key is turned off, the vent solenoid is left open for 10 minutes to allow the system to stabilize. Alright? The ECM then notes the fuel tank pressure. After it stabilizes, you're going to look at the pressure, FTP. The ECM then energizes the EVAP vent solenoid for 4 minutes. That means you're going to turn it on while monitoring the fuel tank pressure sensor for pressure change. You're going to take the first reading and compare it to the second reading. If the system reaches the target value, a change of greater than 1 inches of water from the stabilized reading, the test is complete and the system passes. No leak detected. If the system fails to pass the initial small leak test, the ECM will then command the vent solenoid open for 2 minutes. ECM then notes the fuel tank pressure FTP sensor. The ECM then energizes the EVAP vent solenoid for 20 minutes. In other words, it's going to repeat the test while monitoring the FTP sensor for change. A change in the fuel tank pressure greater than 1 indicates a pass, no leak. So basically, it's going to take that first reading, get a baseline, and run 2 tests on it to see if it's leaking or not. And looking for that, what's it, 1? Yeah, 1 inch of water of change. Vacuum decay is used to test for a large leak. And their criteria for a large leak test: a cold start with engine temperature between 86 degrees Fahrenheit, below 86 degrees Fahrenheit. A cold start with the engine temperature below 86 degrees Fahrenheit. The fuel level between 1/4 and 3/4. Ambient air temperature must be between 40 degrees and 105. Engine is running. The ECM turns on the EVAP vent solenoid, blocking the fresh air from the EVAP canister. The EVAP purge solenoid is turned on to draw a slight vacuum on the entire EVAP system during the fuel tank. Then the evap purge cylinder is turned off to seal the system. Sounds familiar? We just talked about this, right?
Yes.
The monitor uses the fuel tank pressure sensor signal to determine if the evap system has any leaks. After testing is completed, the evap vent cylinder is turned off to relieve the vacuum. A small leak DTC was set if a sufficient change in the fuel tank pressure is not achieved. That's pressure, okay? During a small leak test. Remember, in a small leak test, we trapped the vacuum and looked for a pressure increase.
Correct.
A large leak DTC was set if sufficient vacuum is not created. That's when we close the vent and open the purge. Or it decays too rapidly. In other words, we close the vent, open the purge, right? Then we trapped it, and it decayed too fast. Or drew a vacuum, and it went back to a pressure too quickly.
Okay.
Or does not decay quickly at a conclusion of a large leak test. So a large leak DTC was set if sufficient vacuum is not created. We already know that.
Mm-hmm.
Or decays too rapidly. So in other words, it got the vacuum, but it decayed right back to a pressure too fast. Okay? Or does not decay quickly at the conclusion of the large leak test. So that's basically it. So that's basically for the evap system. Any questions on that? Any of that?